Good morning. It's great to be here. 3DEO is a spin-out from MIT Lincoln Lab. We're commercializing some of that LiDAR technology that Dr. Eric Evans spoke about this morning. The problem that we've taken upon ourselves to try to solve is to create these large data sets, 3D maps over city scales, region scales, very accurate and detailed. Now, LiDAR is the gold standard that's used today. But it's got some problems. In particular, it's kind of slow. There's other techniques that are used, such as photogrammetry, but there's also challenges there in actually using those advanced machine vision algorithms to extract 3D representations of structures. The premise that we're executing is that a new class of detectors enables a whole new class of LiDAR systems. And this has been borne out in the DoD world. We're leveraging that investment on the commercial side. So to remind you, these detectors that we're using are pretty special. They detect and timestamp photons one at a time. So we really assemble a 3D map, kind of one photon at a time. The upshot of all that is that you need about 10 to 100 times less light to do those measurements than the existing commercial systems, and that results in smaller lasers, smaller optics, smaller and more affordable systems. If one pixel is great, tens of thousands are better. So that's the other kind of distinguishing thing about these detector technology is that we put these together into these large imaging arrays. At the end of the day, the measurement rates that you can get is around 10 to 100 times faster. I'd like to just give you a sense of some of this capability by showing you a quick movie. It's a fly-through of a point cloud that was collected over the Boston area. This was collected in about 6 minutes of collection time. That's 2 of these lightning talks, if I stick to the clock. It's about a 10 square kilometer area. This was collected at 13,000 feet. As we start to zoom in, you get a sense of the level of detail that you can get with this technology in very short time frames. You're seeing the tops of buildings, obviously, but you're also seeing sides, you're seeing under the trees, wires, stoplights, all those kind of things. I have to move on. The first application area, our entree into the commercial world, we're anticipating a corridor mapping focus. As you might imagine, public utilities worry about vegetation and other things happening to their lines. They use LiDAR today, but it's just very expensive. What we're anticipating here is something like a 10x reduction in the cost of getting these very dense, detailed 3D measurements of what the current conditions are out there in the field. Moving forward, we're anticipating flight demonstrations of one of these much reduced sensor sizes in the next few months, and then later in the year, executing projects with our pilot customers. Thank you.
Hi, my name is Ophir. I'm a co-founder and CEO of Dust Identity. We're a spin-off from MIT, and we've been working for the last several years with the Department of Defense and commercial entities on really securing supply chains, especially when those supply chains propagate into expensive assets or critical assets such as data centers. And for us, it's really about the ability to trust things. For example, a circuit board, a hard drive, a battery, and it's of course not strictly related to electronics. It can be many other things. It could be a piece of art that you want to be able to authenticate such that you can sell it. There's also security concerns that of course come out with hardware electronics, but there's also a quality and safety concerns that you can have in many industries where the quality of the material that you're bringing into the market can have devastating consequences. For us, the approach that we decided to take is actually to take diamonds that we install an atomic defect inside and spray coat objects with those very small diamonds to create a unique unclonable fingerprint. And we can then consume that fingerprint using a scanner. You can think of it as a credit card where the diamonds on a piece of paper can be the credit card, the point of sale is the scanner, and then we have an authentication engine or clearinghouse that allows us to authenticate every transaction that is made with those objects. And at the core of it, as I mentioned before, is an atomic defect that we install inside the diamond lattice. We actually displace a single atom, and that gives us the ability to very quickly orient the diamond crystal in space. And we can do that actually in parallel to many, many diamonds on the object. And you can, if you look at that circuit board that you see on the left-hand side, there are millions of diamonds on that object, and every small area has its own fingerprint. So we can effectively authenticate any component on that circuit board and associated digital information with it, whether it's writing into blockchains or pulling information that is, for example, a testing manual or installation manuals and so forth. And at the core of what we're doing is actually delivering trusted physical identity. You can think of what we're doing as identity management for physical objects, and it has three specific pillars that is quite important. It has to be unique, so we need to be able to identify every object uniquely in the universe. The second thing, we have to do it securely. Security is very important because when you're consuming data, you want to make sure that it's related to those objects. And it has to be a solution that is agile. We have to make sure that we can go at different parts in your supply chain and your value chain, even after manufacturing, even during service operations. If this was interesting for you, please visit our booth and see a live demo of our solution. Thank you.
Good morning, everyone. My name is Matthew Perlson. I'm a chemical engineer by training, and I have a research appointment in the Department of Aeronautics and Astronautics, where I'm a renewable jet fuel expert. And after about 10 years in doing renewable fuels and large-scale utility-scale wind and solar project development for renewable energy projects, I realized that the most important thing I could do with my time was to come back into the research laboratory and tweak a 30-year-old additive manufacturing technology to make things ultra-lightweight and ultra-strong. So for many people in the room, that photopolymerization or stereolithography might be a familiar technology. In fact, I would bet dollars to donuts that many of the companies in this room have a stereolithography machine in their R&D centers with a single or double-digit serial number on it. And this technology's been around for a long time. It was first commercialized in 1988 by 3D Systems. It was the first commercial 3D printing technology. And the way that it works is you take a liquid photopolymer, you expose it to a special kind of light that would give you a sunburn, and it turns it into a solid. And what's nice about this technology is that, it has superior surface finish and exquisite details with dimensional accuracy that's unrivaled by any other technology. And over the last 10 years or so, a number of other companies have gotten into this market. And in addition to producing the hardware, there's been an explosion in the chemistries that are available. So long gone are the days of it being a rapid prototyping technology, and it's really turning into a production technology. So in one slide, this is what the foam printing project does. It takes regular printing resin off the shelf. It runs it through the intellectual property that I've developed over the last 10 years, and it turns it into a foam. And as many of you know from generally being alive, you can take a little bit of liquid and turn it into a lot of foam. And I use that to the advantage of creating this 4x volumetric expansion, which makes things lighter, cheaper, and faster. And while none of those are an order of magnitude step change by themselves, when you add them together, there really is a value add here. Instead of curing an entire voxel of liquid resin, you're just curing the thin candy shell, and that makes it lighter, cheaper, and faster. So this is it at work, a little animation, and you can see that the foam is being dispensed on the top here, and then swiped over with a doctor blade. And the whole point of this technology was that it could retrofit existing machines. So I've been doing a couple of industrial use cases, working with a major aerospace company on a UAV nose cone, as well as some athletic footwear samples. And I'm here today to tell you about this in case you have an interesting problem that you think lightweight, ultra-strong structures could work with. And I'll be at lunch. Thank you very much.
I'm Christine. I work on Honeycomb.io. I'm co-founder CPO. And many years ago, I graduated from this place with a degree in computer science. Since then, it's become clear that our software world is only becoming more complex. All software systems are going from the monolith that we were previously able to run on 5 app servers to 50 microservices and 500 containers. All software systems are becoming platforms. All software systems are becoming distributed. And all software systems are still held beholden to that one complaint We love to track down users saying it's not working. Monitoring is valuable practice for identifying known behaviors and monitoring for them, checking for them. The problem is, as our systems become harder and harder to predict, we are unable to predict the entire range of problems that we might encounter in production. And we need a methodology, a set of tools that are flexible enough to keep up with the evolution of our software systems. Honeycomb combines the best of monitoring and distributed tracing to provide a fast, flexible software solution for tracking down problems, isolating unexpected behaviors, and reducing mean time to resolution. Engineers use us to make sure that the code that they're shipping, in order to adhere to the agile methodologies that the higher-ups are trying to champion, are being shipped not just faster, but more reliably and with greater confidence. In this way, we are able to make sure that, along with shipping code faster, allocating our engineering resources well, that they are going towards moving the company forward rather than putting out fires and tracking down incidents. Intercom is one of our customers. They're a multi-tenant B2B SaaS headquartered in Dublin. They have tens of thousands of customers. And before Honeycomb, they'd been told, frankly, that they were unable to break down their logs, their traffic, by the thing that mattered to them most, individual customers and their individual workloads. Their vendors had simply told them for years it was impossible. With Honeycomb, they were able to find that one of their 20,000 plus customers was consuming 10% of their entire fleet's CPU, representing 55% of one particularly expensive operation. We are currently working with top engineering teams across a number of different industries. We want to grow. Come find me at lunch. I'll be at lunch, and I want to hear about your observability practices, how you currently track down problems and resolve incidents. Thank you.
At Interpretable AI, we turn data into trusted action. I'm Daisy Zhou, co-founding partner together with MIT professor Dimitris Bertsimas and Jack Dunn. We all know the future of business is artificial intelligence, but for AI to really solve the hardest problems that the world is facing, from building safe, self-driving cars to curing cancer, it really needs to work together with humans. Businesses are realizing this now and are calling for action. Bank of America says they need to understand how the decision is being made so that they can prove to regulators that there is no biases. A recent article in Harvard Business Review says companies are unable to take the full advantage of AI if the employees don't trust it. The FDA chief says that they're not comfortable with the approval of using AI without the level of confidence that we know what it is doing. Collectively, for AI to thrive, it needs to explain itself so that the humans can understand, validate, and trust what it is doing. If we do not understand what the systems are making the decisions that they will eventually break down. At Interpretable AI, we deliver interpretable solutions to your hardest problems. Our solutions leverage our proprietary software modules, each based on years of AI research at MIT. With these software modules as the building blocks, our solutions achieve state-of-the-art performance while still remaining fully transparent and understandable to everyone at your organization. We have established a track record delivering business impact with interpretability. We help a cybersecurity firm to understand the nature of the latest threat. Our major global retail partners are able to trust the assortment planning that we recommend. The risk scoring systems that we build for banks and insurers comply with regulations, whereas black boxes simply cannot prove their fairness. Top surgeons at MGH agree with the interpretable logic from our surgical risk calculator and therefore trust the predictions. We're looking for a number of pilot partners that really need trusted solutions to your hard problems. Come talk to us if you want to improve the level of trust in your data-driven decision-making.
Hi, I'm thrilled to be here today. I'm Melissa Fensterstock, CEO and co-founder of Lansdowne Labs, and we are developing advanced materials for injury prevention. And our connection to MIT is that we're a spin-out from the Langer Lab, as well as a member of the Tough Tech network at the Engine, which you heard about earlier today. So we're a bit different than a lot of companies that you might typically hear about. So we are business model driven in the sense that we're focusing on technologies that are capital light that can be commercialized in about 2 years. So yes, they can achieve revenue in about 2 years. We are working with validated proof of concept technologies coming out of the lab that can be scaled towards the point of commercialization and then sold to a partner who can then commercialize the technology. So our business model is not to commercialize. So today we are developing 2 very promising technologies that are in the adhesive and coating space. The first is a coating for a button battery, which would help prevent tissue damage and possible death by the accidental ingestion of button batteries. So I don't know how many of you are aware, but button batteries are a safety hazard. Children can get their hands on them from remote controls, devices, and often these ingestions are unwitnessed, and permanent and life-threatening damage can begin in as little as 30 minutes. So we've developed a low-cost, highly scalable solution that has received attention from leading regulators such as the Consumer Product Safety Commission, and we're hopeful that our technology will become a standard in the industry. So if there's something that you take home from today, I hope it's that if you have little ones at home, that you child-proof your house. The second technology that we're developing is an adhesive platform, which is addressing this issue of skin injuries and fragile skin. So we've developed a solution that is very strong, so very adhesive, but releases gently, which is a tough thing to nail. And the format of product can be anything from a bandage to medical tape to wearables. So imagine, your mother or grandmother who is at a skilled nursing facility who's constantly getting dressing changes and has a host of medical issues. The last thing that's really on her mind is that she wants to deal with a skin injury. So a little bit of data about what we're working on. So here you can see on the left the control with a traditional button battery. On the right, we have our current design. Obviously, we're optimizing it, but you can see that on the left, it's very significant damage to the tissue in about 30 minutes. And then our adhesive, just a snapshot here. On the top, you see a typical construction of medical tape, which is 2 layers, and you can see the injury from the removal of the tape. On the bottom, we have a elegant design, which is essentially a 3-layer tape that moves the fracture point away from the skin, which allows for easy removal. So how can we collaborate today? I would be very interested in speaking with anybody who's in the manufacturing space or who might be interested in commercializing some of our technologies. We have identified other pipeline products in oil and gas, and just want to say that we have a very talented team who is capable of solving very tough problems, and we're going to solve these as well as others in the future. So please come find me today if you'd like to learn more. Thank you.
Hi everyone, my name is Karan Kashyap. I'm the co-founder and CEO of Posh. Actually, a majority of my team, we came out of the MIT AI lab in the past couple of years with our master's degrees focused on natural language processing. So Posh is a conversational AI company. We focus on context-aware bots. So in the world of enterprise today, chatbots and cognitive agents are becoming a major business trend, and it's pretty clear why. Contact centers are expensive to run. The average call costs over $6. And agents are really high churn. It's expensive to constantly be hiring and training agents as successors. So with all the hype and promise of bots, we find that bots really fall short on one key area, and that's in their ability to understand context. So context. Humans are really good at it. Context is basically the ability to connect the dots between what was said now and what was said multiple steps before. Even the best platforms in the market, like something like Google Dialogflow, only supports 1 degree of context understanding. But why does context matter so much? Well, you can look at the simple financial services example here. We have 2 parallel threads. One is a transaction workflow, and the other one is an account balance check. So they're essentially 2 interleaving threads, and today's bots, by the time they get to the end, they really struggle. They don't really know what's going on. But with the Posh technology, we're able to actually resolve and make that transfer to checking. So we have patent pending IP for a novel way to manage conversation state, and it's wrapped in our proprietary Turing-complete programming language called PAUSE. The primary idea for the platform is that we can basically stop or pause the execution state of the program at any point in time. So the entire process, the threads, the variables, the call stack, can be serialized into a compact byte string, and then it's stored until the next time that the user makes a request. So then the entire process is deserialized, it's remounted back onto our pause VM, and it's continued executing right where the user left off. So a lot of the platforms today, they focus on a stack-based topic management approach, whereas we really view conversations as multiple threads. So we have multiple threads that operate in parallel that can sort of compete for the next input that comes in. When humans talk, they often have more than one thought at a time. We might be talking about sports and talking about Posh at the same time. So it's important for a bot, especially in like a customer service environment, to be able to resolve complex contextual scenarios. And overall, the Posh platform is really focused as a developer platform. We have an extensible API that's able to integrate with anything from legacy cores to modern CRMs. So right now, we're working with customers and partners across multiple industries. Customer service is a big use case, but so are things like knowledge management, help desk automation, and beyond. We're focusing on industries like financial services and utilities, but we're keen on exploring opportunities across industries. Our platform is industry agnostic and works with multiple languages as well. So thank you very much. If you're interested in learning more about our technology, we're going to be at the booth lunch, so definitely reach out. We're always looking for customers and partnerships. Our contact email is there. Thank you very much.
Hi. Great. How many of you work in software enterprises where you develop a lot of software or contract for its development, and it's a key asset for you? Any of you? All right. In how many circumstances do those projects always go well? You're able to adapt those software systems to changing requirements, and as a result, you're able to keep up with the competitors in all cases, right? Okay, no one's hands are up. We, as a company, are commercializing 15 years of R&D out of MIT and Harvard Business School, where we have been able to measure technical health of software assets and also statistically connect this to business outcomes. Here's an example of one of the research projects that we've done. We found that in healthy code bases, people can deliver new capabilities on average in 12 days, how we calibrated it for this study. But in the unhealthy code bases that we've looked at, that might take 80 days. So very significant differences in economics and risk associated with development, depending on the technical health of the assets that you own. Now, over the past 15 years, what we've developed is, first of all, an ability to measure technical health. Specifically, we're looking at the health of software architecture in code bases using graph theoretic techniques. We can visualize these systems. We can measure them in a variety of different ways. The second thing is that we can statistically correlate these with things like developer productivity, defect density, schedule slippage, and other things that would be predictive of your ability to function well as an organization and be lean and agile. The third thing that we can do is that we've developed technologies for helping measure the ROI of different interventions, right? If you've got a large portfolio of software assets, maybe you've got 1,000 different code bases or 1,000 different projects going at the same time, which ones should be left alone? Which ones should be refactored? Which ones are just too far gone and you should completely rewrite them? If you can make that decision in an optimal, model-driven and data-driven way, there's a lot of money and pain that you can save across your organization. Right now, those decisions are made in a highly subjective manner, and there's a lot of money being left on the table as a result. And finally, we have developed algorithms to help people improve the technical health of these code bases so they can drive quality into them and keep them stable going forward. We've done a lot of work over the past few years with the Department of Defense. These are 85 systems that we've evaluated across a large, complex portfolio. And in some cases, the predictive analytics said that we should repair systems. Our tools have been used to help them improve code bases dramatically and achieve significant ROI as a result. In other cases, recommendations were to replace them. In this particular example, in System Y, $2 billion were spent on a replacement, but they would not have been able to make that call if they didn't have a model to tell them how to do it and to justify those courses of action. So we would love to work with you if you have software or if you have portfolios of software and you want to experiment with data-driven ways of managing those portfolios to reduce cost and risk and to drive agility and results within your organization.
Good morning, I'm Chris Hartshorn, I'm the CEO of Zybus Systems. We spun out of MIT a couple of months ago, ostensibly to commercialize a new sensing technology from Tim Swager's lab. Our first stop that we're going to make is going to focus on developing the fastest, most agile food safety testing technology that exists on the market today. Food safety, it's a big market. I'm not going to pretend we're a market maker out there. Depending on how much you pay your consultant, they'll give you a number between $10 and $15 billion in terms of market size. 300 million tests per year for pathogens alone in this space. We're not trying to make a market, we're just trying to take it. The problem with this market is the technologies that exist today are too slow. So culturing in the order of days to get to a result, to tell you what's in your food sample. PCR and its cousins in the order of large numbers of hours, and then the various immunological approaches that are out there, same thing, right? They're all too damn slow. We're going to solve that problem. We're going to take these numbers down by an order of magnitude, is what we're capable of doing. How are we going to do this? Well, this thing came out of a Swager Lab thing, so you can assume there are clever materials in there somewhere. It's predicated on a smart droplet technology. What you're watching there is a two-phase colloid that switches in real time. That is a real-time switching that you're seeing based on the solution that that colloid is in and the analyte that it is sensing. Real time. So we're switchable. We can tune the surface of that microbiologically or with anything you want, in fact. But microbiologically is what we're going after today, so it can sense microbiological organisms in that fluid. And that colloid behaves like a little microlens. So we can detect that change using very sensitive optics and a very sensitive optic response that comes off that material. So we've got a bunch of stuff going on in there. We've got materials development, we've got biotech development, we've got optics and electronics development, each of which we're on a course to developing, each of which we would love to work with companies on and partners on to accelerate our development and accelerate your innovation pipelines. In terms of the market, this market is highly segmented, we know that, depending on food and beverage category, depending on organism, depending on who's doing the testing, depending on what sampling point you're using. We're going after all of these things, but we are trying to select these things carefully. The biggest opportunities are not always the fastest opportunities in this space. If you're in the food and beverage space, anywhere from source, from growing this stuff, through to consuming it, I would love to talk to you about the market, just as I would love to talk to the technology developers on how you can help us as well. So the executive summary, we're going to be fast, we're going to be agile in terms of form factor, we're going to have broad coverage, and we're going to be low cost. What we're looking for is technology partners, and we're looking for market development partners as well. Thanks for your time. I'll be at lunch with everyone else.